All right, so let's go ahead and create a script that is going to move our trunk NPC here. So let's just go inside of here, and in our scripts folder, we really only have one so far, and that's the player. I'm going to create a C# script, so model behavior script here, and I'm going to call this enemy movement. So let's go ahead and open this script up. All right, what I'm going to do is just kind of type out the code just to save time, because a lot of this stuff we've done before. And then I want to take some time and just show you a way of rewriting if-else statements. And I'm going to add a little bit more. So let's get the basics down before we refactor our code. So here I went ahead and created 3 public variables. We can make them private and serialized fields, but just to show you. And this one is for the movement speed of our enemy. And then we have the transform, which is an empty game object placed at the enemy's feet. And what this is going to be used for is just checking if we hit the ground. And we'll add that in a second. And then we have a public layer mask called ground layer. And then we're going to set this to platform, which is the name of our ground layer. So let's go ahead and select our truck NPC and create an empty object here. So I'm just right clicking in this, and you can hit Control-Shift-N or hit Control-Shift-G. So let me show you that. So Control-Shift-N, you can see. And I'm going to name this, oops, looks like I copied all my code there. Sorry, let's try that one more time. Control-Shift-N, and then I want to call this ground check. And I'll capitalize the G just because everything else seems to be capitalized. And I'm going to make sure that this is a child of this. And when I select my trunk NPC, I'm just going to grab this and ground NPC here. And looks like I did not add this enemy movement script, so I'm going to go ahead and do that as well. Grab my ground check and move it there. Now for my ground check here, you'll notice if I hit F, it's way out here. Let me hit W here so you can see that. So I'm just going to reset the position. And then I'm going to move this to the feet of my character, just at the base. And let's add one more Boolean to check if we're moving right or left. All right, so this Boolean is just going to check, is my character moving in the right direction or the left? And that could be easily checked by, if you look at the position on X, oops, here's our X. And you could see that, for instance, we know we're moving right if our character is, the value is going higher. If the value is getting lower, we know our character is moving to the left. So left negative, right positive. I don't need this start method here. I'm going to pretty much do everything in update and then extract it later when I go to clean up my code. But again, like I said, I generally come from that rule of thumb where I like to just get it working, and then I'll try to slowly clean up or refactor the code. All right, so here's my update method. Now, remember, we have this move right here, which is just really just saying it's set to true automatically, which means it's set to, it's positive, right? Like it's a Boolean or a check mark. Yes, this is checked on. And if you need to see what I'm talking about, I can just add a serialized field here. And I'm going to save this, and you could see, just for a reminder, what this is really doing is saying, hey, is this variable set to true or not? And you could see right off the bat it's checked on, which means it is set to true. Now the ground layer here, it says nothing right now, but we did make it one called platform. Remember that, and that's what our platform is set to. Not platform grid, but our platform tile map is set to platform. So that's what's going to be used to check the ground on our character here. So if we go through this, in update, this runs every frame. And really we could, and we should kind of grab all of this. And we'll just do this now. And this is really what's moving our character, right? It's checking if transform.translate, vector2.write, move speed, all that stuff. This is what's actually moving our character. And this is what's actually checking if we have a ground. So we could extract this into 2 different methods, but I think that's overkill if we're only doing one little thing for checking the ground. So I can hit Control period here, extract method, and just say move enemy, or it could just be move, and then hit next. And that'll call move enemy every frame. So that's kind of part of the extracting I was talking about. But it's pretty simple code, like I said. If we are moving to the right, which means that's set to true, I want to say transform.translate vector2 right. That means like we're going to move it to the right, times move speed times time that delta time, right? So this vector2 right is the same thing as saying, hey, move this character on the x-axis to the right. That's what this is saying here. If we're not moving to the right, I want to move to the left. Well, how are we checking? Like, what is our, how are we knowing whether we should move left or right? Well, that's what this next line of code does here. Let me go ahead and put this on a new line, I think. Yeah, let's break this into 3 sections so you could understand this a bit better. We'll break it into 4 rather. Okay, the first thing is these raycasts are, actually, you know what? Let me add a little bit of code to show you how you can see a raycast. But a raycast is essentially from the transform of whatever this is. So this is going to be the ground check position. This is the origin of the raycast. It's going to shoot like a laser. And the distance it shoots the laser is set by this value. And then the direction that the laser shoots is this way. So let me go ahead and just add a bunch of code, maybe below update here, just so you can visualize that laser. All right, so I know this seems a little scary, but don't be afraid. Up at the top, I added a ray distance. All this does is it's a float value, which means it's a number with a decimal. And it just is, it's going to control how far the ray shoots from our character here. And you'll see it pop up here. So this is our ray distance here. So if I press play right now, it's kind of showing you, let's see, you can see there's a little red line there. And that's what's casting to the ground. And it's making our character go back and forth. See how it's stopping at the edge if it doesn't hit that ray? So what's happening here, and I could break this out, and I will in a second. I'll just call this raycast or something, a raycast calculation. But we have a vector 2 here, which is an x, it holds 2 values, right? X, Y, X, Z. This is vector 2, and it's saying direction. This is a ternary operator. And what this is saying is if we are moving right, if this is true, which is move right, and I'm going to show you, if this doesn't make sense right now, I'm going to actually refactor this code with you in this video to show you how to use this. What this is saying, if we are moving right, if this is true, this is like an if statement. If we are moving right, then we want to move this vector, we want it to check to the right, right? We're just setting the direction. Otherwise, set it to the left. And this is what casts our ray downwards, right? So physics2d.raycast is a Boolean value. So this says ground ahead. This is just checking if it's true or false. And what this is saying is we're going to cast a ray if is our variable, like we're casting a ray downward to detect if there's ground. And this is just saying it's true if this raycast, we're checking the position, ground check that position. Remember, this is the origin. So from the center of this ground check downward, we want to start the raycast. And which direction are we shooting that laser down? Let me go ahead and press play and pause it so you can see this. This little laser here, I don't know if you could see that. This line, it's saying we want to face it downward. And then we want to base it, the distance is based on this ray distance here, which we set to 0.93. And then what are we casting a ray against? What are we checking? Well, we're going to check the ground layer here. Now the ground layer here says it's an integer here because these are all set to a value. Now we want to cast the ray forward to detect walls if this Boolean here, right? We're checking this wall ahead. So we have a, let's see here. We'll check, we have this, it's going to cast the ray forward to detect walls. This is wall ahead. And the way that this works is if wall ahead, which means the ray itself is it's transferring the position, which is from the center there. And the direction it's going is going to be forward. And it's the ray distance, and it's going to check for the ground layer. So this is how it's checking if we bump into a wall. And this is how we could turn around too. We could probably even have this cast against the player. Now the draw ray cast, this is what's actually making that laser look red here. And there's 2 of them here. And it says here, this is to detect the wall and this is to detect the ground. And how do you know that? Well, if you look at this one, it says vector 2 down, and this is just direction, which means forward or back. So you can see here, there's a little blue line here, and that's detecting the wall. So if it hits a wall, we're going to flip the character, right? So let's actually put this guy down here because we do have some walls to check. And let's go ahead and stop this for a second. I'm going to move him down here, and you'll be able to see this a little bit better. And you could duplicate this guy on multiple locations. So here's our character, and I think he's flipping out because of the shape of my caster here is a cube. And is it checking the ground? I might have to change this from a box collider to a sphere. Let's see, sphere collider 2D. Oh, let me go inside of my Wait, why is it? What did I say? Oh, I need a 2D sphere collider. So I think it's circle collider 2D, yeah. And then let's just scale this down. See if that does it a little bit better, because the cubes tend to catch a little bit. And then I have to do that logic I showed you guys before where, actually, I think we could just do it now. Where's that at? Rigid body. We want to do continuous. Let's see if that works. It's still catching. Let's see what this error is. Here, I'll fix that in a second. For now, let's just get this logic one problem at a time. So let's press play here. Okay, so he's moving, and then he switches directions. So what I might do is, with this trunk NPC here, I might just start him off as flipped. Oh, it should be -5. Now he's facing this direction, and as he goes, that way he'll flip when he reaches the end, and then he'll face this character. Okay, so that's what this does. So one problem at a time. Now I notice this new issue, and we'll go ahead and fix this. So here's the code that moves our enemy. And this is stuff we're going to refactor and turn into a ternary operator in a second. All right, sorry about that. Okay, so a little bit of edit there. Had my my recorder closed. All right, so let's move on. So check if there is a ground ahead. So this is our move enemy, which is called every frame, right? So we can even, like I said, grab all of this, just hit Control P, and just call this, we go to extract this method, ray cast calculation. And the reason why I didn't call it like calculate raycast or something is because I want it to be really explicit that this code here handles raycasting, and I'm putting that. I'm going to hold Alt and push the up arrow. I want this above my move enemy. So this is called, they're both called an update. So here's our move enemy method. We're going to check if it's true, if it's moving to the right. We're going to check if it's not moving to the right, that means we're moving to the left. Now we want to check if there's ground ahead, and that's what this is doing, right? So Boolean ground ahead, physics 2 raycast. And this is going to look very similar to this up here, which is just shooting a cast downward. But what this is doing is it's setting ground to true or false if we hit the ground, right? So this is saying it's checking that raycast, and if it's facing downward, and then we're going to set ground ahead equals true, right? And if we get there and this is false, which means we get to the edge and there's no ground ahead, what we want to do is we're going to, again, this is going to be set to essentially false, right? Because we have no ground ahead. That's where we have this if statement that calls this flip method, right? So this checks if we have ground ahead, and this checks if we have a wall ahead. If we have ground ahead, right? If we do not, that's what this exclamation point means, we're going to flip the character. Or if there is a wall ahead, which means that this calculation is true, right? We're just checking a raycast from the position, the center of that ground, you know, the position of the character, which is here. You'll see a blue line going that way. Or, right, this is the ternary opposite. So it's the same thing. It's just saying or. So if we are moving right, or we have a vector 2 right, which means we're moving in the right direction. If moving right, which is, you remember, we're calculating that here, right? This Boolean variable here. So if this is true, that's what this ternary operator is. If this is true, we want to move to the right, right? Because the value of our trunk goes up. That means we're moving right. If this is set to false, we're going to move to the left. And the distance that ray is going is 0.1. And really, I should just kind of double up this and just call this like, you know, grab my ray distance from here. And I don't know why I just kind of hard-coded that. That's like a rule I don't like. And then this is the integer set to ground layer here. So they're both set to whatever the ground layer is, which is platform. I should call that platform layer. And this is what's actually flipping our code. And so let's take a look at that. So move right is the same as not move right. So what this means is once we flip our character, we're going to set this to false or true. That's what this not move right. So whatever it currently is, we're going to say it's not that. And this is what helps us constantly set that Boolean to true or false. Now this is what's actually doing the flipping, right? And we've seen this before with our main player. All this is doing is it's saying, hey, whatever the scale, the local scales of our characters, we're going to make it negative. So a -1 to 1, right? Or a 1 to -1. Well, they both equal 0, but like You take a negative, right? And then you make it, -5, and then you're like flipping that value. So this becomes a positive. And then we're going to keep our y-axis the same, and we're going to keep our z-axis the same. That's why we're just writing local transform. So let's press play and take a look at that in action. And then I'm going to show you how to convert these if statements into these much cleaner ternary operator statements. So here we have it. You can see there's our blue thing. And honestly, they need to go much wider than that. So I should actually set this to, because I don't know if that ray needs to be that long, but so let's just call this forward ray distance. I'm going to capitalize that R. And then I'm going to grab this value here, and I'm going to just paste it inside of that, my raycast checking forward. So here, and then when we're actually moving our enemy, where is that? Here, wall ahead, here. And then just to show you the difference, if we go back inside here and select our truck NPC, and I change this forward ray distance to like 2, and I press play, you'll see a very long blue arrow. But this is also, depending on how far this is, here, let's go ahead and add let's grab our, let's see, let's also figure out, like, here's this. Maybe it is my ray distance is just too high. Let me make this 0.1, but then again, it really shouldn't get stuck. So let's press play here. Yeah, it is just too long. That's all it is. And you see how this is super long and it just stops way up here? So we might want to make this one even 0.5. That's the forward ray distance. Yeah, let's make this much shorter. So you can see if I make it much shorter, he'll bump right up against his nose. And it looks like 0.8 is the value I'm looking at there. Okay, let's save this. Now let's take a quick look at how we can, and we'll just really do this. Let's see. A look at a way we can clean up our if statements so that our code looks more compact. So we have this if move right and this else move right, and it's based on this move right variable. So I'm going to highlight all of this and just hit Control K and C just to comment that out. And then I'm just going to paste this line of code here. Actually, you know what? We'll type it out. So we know what transform.translate here, right? This is what's moving our character. Okay, so what I want to do inside of here is a couple things. I'm going to say, hey, and we're going to do the actual checking, the ternary checking that I was talking about inside of we're going to set another brackets to kind of really focus on this. So what we're saying here, move right, right? Is this true or false? Now, if I hit I add a question mark here, oops, at the end of this, what this is going to tell our compiler is, hey, if move right is true, I want to do this first thing, which is I want to do vector2.right. Actually, let's just do it this way to so you can kind of see it a little bit cleaner. Vector2.right. If this is true, I want to move to the right. Or, where is my colon? There it is. If this is not true, I just want to move to the left. So this makes our code a little bit more compact. See how I'm just copying from both of these? Now, if I'm moving left or right, that's where this other good stuff comes in, right? Like I can say, okay, whatever direction I'm going, I want to multiply that by move speed and time.delta time. All right, let's save this and let's take a look at how that looks. So now you can see it's doing the exact same thing as this. So you can really just delete this. And now you can do that whole entire if-else statement inside of one ternary operator, which is kind of a very nice way of cleaning up your code. And it's new, so it might be confusing. So you might want to practice it a couple more times. It's the same thing in our, let's see up here. This is the same chunk of code that's up here inside of our raycast calculation. We have vector2 direction move right. If this is true, we're going to check our vector from the right. If we're moving left, we're going to set our vector to the left. That's what's making our vector switch direction too. I think that was a lot for this tutorial. I hope it was easy to understand. We've talked about enemy movement in the past, and Yeah, I think that's cool. I mean, what I would start doing now, just to have fun, is don't even use the same character. Like, remember, we have this whole nother sheet here. So let me kind of show you a trick, right? So I'm going to select this guy. I'm going to hit Control D, move him up here, right? And you could just change this to another variant by going to the sprite renderer here, clicking on this. And, well, this guy's already idled. I would just make a new character, right? Like, go ahead and go inside of here, retrace the enemy prefab. Like, don't just do what I have left. So remember, we have this Pixel Adventures 2 assets, enemies. Maybe make the Angry Pig one of your characters, right? We have all this great stuff. We have this bee, maybe use a bee. We have the attack, we have a hit, we have an idle. For now, I'm going to keep it the same just because of the time it takes to, I'm recording these for class, and I'd probably create my own art anyway. But now let's go ahead and press play, and you can see here, I'm going to go ahead and play my game too. So yeah, so this is the same thing. You almost want this character to be down here. Now what's really neat is, because these are independent of each other, this trunk NPC, we'll just put a 2 here or something. If you notice that it's having that issue, you can just go into trunk NPC 2 here. Let me go ahead and remove this box collider. I think you could have kept it, and I'm going to say, you know what, this ray distance is too strong for up here, so I'm going to make that 0.2. And hopefully it doesn't make my character catchier. Yeah, there we go. So now he's moving. And then my game down here, I can kind of jump over him. And we don't have anything where they hurt our player yet. But now we've got this really great movement. I mean, the player movement still bothers me a little bit, the camera stuff, but we've got some great enemy movement.